2, here's the calculator stuff, and we want to put these into y equals. I said you could put it in y1, do each one individually, or you can put them in y1, y2, and y3, which I'll show you how to do that. The deal is plug those in, and we're going to get domain and range, but you're going to run into various errors, not going to see the graph, that kind of stuff. And I'm going to try and explore a number of those different errors that pop up right now. The first one is if you do x over x squared minus 9, anytime you have a numerator denominator in one of these rational expressions that has more than one term in it, you're going to want to use parentheses just to make sure it keeps grouped together. So I need to put parentheses around x squared minus 9. And that way, everything stays peach keen. You divide the whole thing by x squared minus 9. And if I just randomly go in there and say, hey, hit graph, what's going to happen is it's going to just take the last window I used for whatever I was graphing. Yesterday we were plotting stuff, so it'll probably fit to some plot that you have. And you'll hit enter, and there it's just graphing this, and you see little blips in here, looks like a heartbeat. There's my plot of graphs. Yours will probably look different. Some of you will get this message called error dimension mismatch or wrong dimensions. That would be common in the situation as well. Both of them stem from this. If you go back to y equals, and you go up on top, see that plot 1 that's darkened in? That means it's on. We don't want plot 1 on while we're just graphing regular graphs. You turn it off so those dots aren't plotted anymore. If you just hit enter on something, it'll go on and off. Darkened means it's on, and light means it's not. And there's our graph again. If I hit graph, same thing happens, just missing the dots. Again, it's not a really good picture. I kind of don't know what I'm looking at. The options you have are, often we like to use kind of a standard window. So you can do, which is a standard 10 to the left, right, up and down. Or you can zoom and fit it. And all of the options for making a graph look better are under zoom. And I'm going to try zoom standard because it's a good place to go. So I have a pretty good habit of saying zoom 6 to get a decent start, and then go from there. Take a look at it and go, hey, not bad. Zoom 6 seemed to do the trick. I seem to have the image of the graph. I could sketch it here on the paper and be able to make some conclusions about it. I think I'm happy with this one. Your other option is zoom fit, and in this particular case, it does a reasonable job of making the graph fit as well. So zoom and fit is, I think, if you go below zoom stat, it'll pop up as one of the letter options on this calculator anyway, I think. Yeah, 0th option, zoom 0 will get you there. Now, back to the drawing board. So let's say we got that one nicely graphed to go look at it. The domain and range question over here on your worksheet, for domain, the lowest your domain gets looks like, and remember that's x's, the lowest x, it goes way off to the left, like completely to the left. So it's actually negative infinity. I can't write the infinity symbol as is now, but I'll put inf. And then the upper, it goes along. There are some issues. I noticed that there's little breaks in that graph, and that's actually something we have to account for. We can't, if the domain is about what x's are possible, you realize there's some blanks in there. And it looks like it's like maybe 3 over to the left and right. Well, look at the original problem. The denominator is x squared minus 9. If you put 3 in for x, you get 0 in the denominator, and that's illegal. You get what's called a vertical asymptote. So there are vertical asymptotes in -3, likewise. Same thing, you divide by 0. That's what you're seeing as our vertical asymptotes, because those are the x values we can't put in because they cause division by 0. So what you really see are 3 chunks of graph. So what we're going to do is do 3 little chunks of domain. I see a lot of graph from -infinity to -3. So -infinity to -3, that's one part of it. And then I see some more graph from, looks like -3 to 3, between those two. Remember we were doing that between notation yesterday, -3 to 3. So somewhere between there. And then I see it again after 3. So 3, and it seems it goes and goes and goes and goes, so 3 to infinity. Those are the 3 little chunks. Now parentheses are important in this case because -3 and -infinity to -3 says, from -infinity to -3, not including -3 because we know that's a problem area. The middle one goes from -3 to 3, both in parentheses, because you can't actually go to -3 or 3. So parentheses indicating that, and so on. Okay. Now what we often put in here in between these two is this cool symbol called a union symbol. And I think, I can actually do that here. I think there's a cool little insert symbol option on here. And I just got the update on my Mac on all the new things. Where are my symbols? Word art symbol, something like that. But usually I can insert some kind of symbol really fast, and I have to go about it a different way. Anyway, I'll go back and find it because I'm updating my Word and everything moves around a little bit. But if you guys see it on there, insert text box, word art symbol, something, something. We'll find it later. But you guys can put union symbol, which is basically a big U. Range. Range is the lowest lowest y to the highest y. If you look at this graph, the lowest it seems to go is way, way, way down there at negative infinity. So we go negative infinity. Ooh, I like the purple I was writing in before. The negative infinity to, in this case, it looks like it goes all the way up to positive infinity. I'm wondering if we have that break again. Remember last time we had the x's, we kind of accounted for breaks. It looks like there's kind of a weird break in the here, but if you actually think about it, there is a graph that exists all the way throughout this middle section. There's never a break. There's always some value between negative infinity and infinity. So our range is actually negative infinity to infinity, different from our domain that had these breaks, these vertical asymptotes that are along the way. So there is an interesting thing we can talk about later, but vertical asymptotes, you can never cross them. The graph never touches. Horizontal asymptotes, which is actually what you're seeing here, kind of a break in the graph, but it's a horizontal. You can cross a horizontal asymptote. So a horizontal asymptote is more passive. You can cross it. The vertical asymptote is one of those stubborn ones where you can't cross it. Never cross a vertical asymptote. But the implication is on a horizontal asymptote, you can cross it, but at the extremes, your graph kind of snuggles up against it. And graphs always hug asymptotes. And horizontal asymptotes, here's a graph definitely hugging something along the way. So we'd call that a horizontal asymptote. Now, 2 to the x. Let's get to that one. I'm going back to y equals. You can either graph a brand new one in y1, or you can hit enter on the equal sign in that y1, and what you end up with is that graph no longer graphs, and I can do 2 to the x. So if I 2 exponent and then x, like that, that's my 2 to the x. If I hit graph, it's just going to take the window I just finished with. So here we go, here we go, here we go. Which is not bad. My standard window did the trick. So if you notice, Zoom Standard it's a good place to start. Gives you a place to work from. So ta-da, there's my window. Domain on this one, smallest x, that graph just keeps going, is negative infinity. And interestingly enough, the biggest x will get, it just keeps going, 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 going. So you can go as far as you want in either direction. So we'd say that's negative infinity to infinity. And if you want to do that cool all reals double back to R, go for it. I can't type very well in Word on here, so usually I would use my iPad to annotate this and write on it, but for whatever reason my iPad is not connecting to the right wireless network, so I can't hook into this, which is, it's goofy. Good old technology. Okay, so domain is possible x is the lowest, so the farthest it goes to the left, the lowest x is negative infinity. The biggest x I could put in is positive infinity. That's my domain. Range is how low does it go vertically? What's your lowest y? Well, there's no graph down here. It's not -5, not -1. The graph doesn't even start until 0 at a height of 0, a y of 0. And it doesn't actually touch 0 because this is an asymptote. This graph gets infinitely close to the axis but doesn't really touch it. So this range is 0, and the highest it goes is all the way up to infinity. But it doesn't touch 0, so there's a parenthesis there. And by the way, infinity always gets a parenthesis as well because it's actually not a known number. It's an idea. It's a concept. It's the idea of something that just keeps going forever and ever. So those are the domain and range. Lowest x, highest x for domain, lowest y, highest y for range, accounting for any breaks in the graph if you need to. All right, so next is the x cubed, the cubic function. I'm going to put that in there as well. Now, all this stuff we're learning about functions is when you graph in a calculator will graph anything you want, but it doesn't fit the window very nicely. It doesn't find the graph automatically. If you use, if you're doing homework and you're trying to graph it and do the domain and range, if you do the Desmos calculator, the MO, as we like to call it, the DeMo calculator, us Iowans, the DeMo calculator will definitely find a nice window for you almost automatically. So it's a good tool to use if you're on your computer and you have that up there and want to graph it. But in school, we're not going to have access to that, especially during any assessment stuff. So get used to using your calculator and finding the window and using your smarts and what you know about functions. Like cubics. This last one is a cubic. I know what cubics look like. They're snaky. They do an S symbol. So when I graph this, I'm looking for the S. If I don't see the S, I adjust the window accordingly so that I can. All right, so down here, we're going over. We got x cubed. So if I can do this right, x to the third. And when you're in exponent mode, don't forget you have to hit a right arrow to get out of the exponent. I always mess that up. Minus x squared minus 65x. Got it. And plus 235. Bingo. And if I hit graph, it'll just use the last window I had. I hope it worked. Oh, yeah. No, don't see the snake. I just see a line a little bit off to the side here. So obviously my window isn't big enough. So you can do zoom fit if you like. You can do zoom. Remember, zoom fit is the 0th option if you go all the way down. Zoom out. You know that we're looking for more graphs, so we can always zoom out and make it bigger. You could even be more precise and say, I think it's up there. I just need to get it taller. And if you look at window, might have been a long time since you've hit the window button. The window button tells you exactly how big the dimensions are, and you can adjust them. My Y max is not high enough to see what's going on, so I'm going to put in some big numbers. Let's go 200 on that, just to really see stuff. And, ooh, still not enough. I made my Y max. Oh, but I see more. See, now, by putting in my window and adjusting it, I just changed my Y max to 200. I afforded more height to see what was up there. I'm seeing that I'm on my way to seeing that graph I know and love. All I need to do is make that window a little bit bigger. If you did zoom fit, you probably got this already, but it's good to know the process of getting there. Let's go 600, because it looked like I could triple this and be just fine. And you can choose your max. I just wanted it enough to capture the whole thing. Oh yeah, there it is. Here's my cubic. That's all of it. I know I have all of it because I know what a cubic is supposed to look like. And that's what basically we learn about functions, is you have to have a sense of what to expect, because computers are dumb. They'll come up with whatever it thinks you want it to come up with. Ultimately, though, you have to rein it in and make it useful. So domain on this one, how far left, what's the smallest x, biggest x? All reals on this one. Negative infinity to infinity. And range, same thing, lowest y to highest y. This graph goes all the way down and all the way up. So we say all reals or negative infinity to infinity. You can choose. I want my purple. Put the purple back. There, got it. Next, calculator trick time. This is not so much a trick, it's just the idea that there are cool ways to get an input-output process underway. So if you would, we're going to graph one more of these. So I'm going to go over here to y equals. And if you keep clearing out your graphs and just writing new ones, that's fine. But I really like to put them all in here, hit enter, and just kind of turn off each graph. But let's just say you've been putting it into y equals all along. I'll play along. Let's go, you just go clear. You can always clear out a function. Whoops, I guess, if you hit clear hard enough. And hit clear. Delete seems to do a decent job. Clear. Done. So I'm going to go up here and put it in y1 for fun. Let's type out 3x squared. And let's get rolling. 3x squared. You can do the power of 2, or you can use the squared symbol. It's up to you. And minus 0.2x, minus 0.2x. Your calculator thinks of the minus and the negative as different, so beware if you have an error with that. Sometimes it's just that you used a negative when you're supposed to use a minus, and so on and so forth. Plus 37, plus 37. If I hit graph, it'll just take the last window I used. Yeah, worked. What do you know? Not too bad. Not at all bad. We can use that and go with it. It gives us everything we need to know. So this is what we're going to actually try and evaluate this function. This is function notation for, hey, in this function, I'm going to substitute E2, negative 3.4, and 107, and see what I get as an output. But I'm going to do it in 3 different ways. So if I wanted to get f of 2, put 2 into the function and see what happens, there's an option under trace. So I'm going to hit the trace button. So it's right after uno, dos, and then there's trace right there. See it? See it? The notes you want to take right now are button presses I'm going through right now. I'm not going to write this stuff down. You can write whatever you need. But the trace option is if you hit trace, you can scroll around on the curve. Trace actually traces along the curve, and you try and find x equals 2. You're looking at this number here going, I want to land on x equals 2. Dope. It keeps jumping. No, too far. Oh, too small. Too big. Too small. You can't land on it. Well, there's a precise way to do this. You can actually, if you just type 2